Hello everyone and welcome to my YouTube channel. In today's video we are going to discuss about few methods of numerical integration. Many a time we come across a function which is very difficult or in some cases impossible to integrate. For example, think of integrating square root of sine of x or the integral e raised to x square dx. Many a times it happens that certain numericals are very tedious or certainly impossible to do. For such integral numericals, numerical methods comes into action. In this video, we are going to discuss three methods of numerical integration. The first one is Trapezoidal Rule. The second one is Simpson's 1/3 rule. And last, Simpson's 3/8 rule. Let's start with the trapezoidal rule. I'm going to keep this video short, and as a result we will not be discussing how and what the trapezoidal rule is. Instead, we will be seeing the working rule of the trapezoidal rule, which helps us to solve integrals. So the idea goes like this: we will be given an integral from, let's say, a to b f of x dx, and this we are going to evaluate as h by 2 times capital X plus 2 times r. The letter h represents here the step size. So it is the length of the subinterval in which we break down the interval AB. X is the sum of extreme ordinates, while r is the sum of remaining ordinates. Let us understand the working rule of the trapezoidal rule by means of a numerical. So here we have evaluate integral from 0 to 1 square root of sine of x plus cosine of x with respect to x using the trapezoidal rule. What we are going to do first is we will be discussing about the formula, what all things are there, and then we will get on to the working of this. So as you can see, in this case the lower limit is 0, so that represents the number a, and while b is equal to 1, and then f of x in this case is the square root of sine of x plus cosine of x. Now first thing we need is h, which is the step size. So for h, the step size is determined by the ratio of b minus a by n, where n is the number of subintervals that you wish to break the interval 0, 1, 2. So for example, let's say this is the x-axis, and here we have x is equal to 0 and x is equal to 1, which are also the values of a and b. Now if I were to break it into three parts or three subintervals, so this 1, 2 and 3, so in this case we have the value of n is equal to 3. Now the higher the value of n you take, the better is the answer which you are going to get using the trapezoidal rule. So for the purpose of solving this numerical, we are going to take the value of n as 5. So in this case we will be having 1 minus 0 divided by 5, which gives us the value of h as 2. That means the step size is going to be 0.2, and this step size breaks our interval 0, 1 into 5 equal parts. So this is going to be, say, 0.2, 0.4, 0.6 and lastly 0.8. So once done with this, we can move on to the next calculation. So for the next part, we will have a table of values. So we'll make a table wherein we'll have first column as I, then followed by xi and yi, which is evaluated as f of xi. In this case, it is going to be square root of sine of xi plus cosine of xi. Since we have divided the interval AB, that is 0, 1 in 5 equal parts, I starts from 0, 1, 2, 3, 4 and 5. So in a way you can say that these are the 6 endpoints which are going to break your interval 0, 1 into 5 equal parts. Now xi, that is in this case the first one is going to be x0. So x0 is nothing but a, which is 0. Then x1 is going to be 0 plus the step size, which is 0.2, which gives us 0.2. Then likewise x2 is going to be the previous number x1 plus step size, which gives us 0.4. On similar grounds, we'll get x3 as 0.6, x4 as 0.8 and finally x5 as 1. Now, two things. One, that since the integrand is in terms of trigonometric ratios, it is advisable to set your calculators to radian mode. And second thing, since the number of decimal places is nowhere mentioned in the numerical in the question, so you can recall what your instructor has told you. So I prefer to take either 4 or 6 decimal places. So in this case, I'll be preferring to go for 4. So these two settings you should make on your calculators before you even start solving the numerical. Now let's talk about yi. So since I is equal to 0, we will be getting your y0, which is equal to square root of sine of 0 plus cos of 0. So this you can directly feed on your calculator, and I'll be getting the value of this as 1. Now I'll not go around and do all the yi calculations. I'll just show you one more for y1. So y1 is going to be sine of 0.2 radians plus cosine of 0.2 radians. So this again you can feed on the calculator, and the value which you should be getting is 1.0857. I'm using a scientific calculator which is 991 ES plus. Now for y2, I'm going to set the value of x as 0.4, and that gives me the value of y2 as 1.1448. Then setting x equals to 0.6 gives me the value as 1.1790. For 0.8, it is 1.1891. And lastly, for x equals to 1, it is 1.1755. Of course, there are certain things which are not necessary. For example, you could skip these things. After the table of values is ready, we can move on to the calculation of the integral. So have a look again here that the integration is evaluated as h by 2 times capital X plus 2 times of capital R. Now h we already know that it is 0.2. Now let's talk about x. So x happens to be the sum of extreme coordinates. Extreme ordinates. So in this case, if you will see, this is y0, y1, y2, y3, y4 and y5. So the extreme ordinates are y0 and y5, and the other ones are the remaining. So sum of extreme ordinates, that is going to be y0 plus y5, and that we get as 1 plus 1.1755, which equals 2.1755. Now likewise R, it is sum of remaining ordinates. So that's going to be y1 plus y2 plus y3 plus y4, and that turns out to be 4.5986. So having these two values ready, we can talk about the integral. So therefore, integral from 0 to 1 square root of sine of x plus cosine of x dx is equal to h by 2 x plus 2 times r. This follows from the trapezoidal rule. So this is going to be h is 0.2 divided by 2. Capital X we have got as 2.1755 plus 2 times of r, that's going to be 2 times 4.5986. Now after this, you can just plug all these values on the calculator, and the value that you should be getting after this is 1.1373. So this is the required integral answer. So it's pretty simple to understand the working of the trapezoidal rule. So what you got to do is you got to identify the limits, lower limits and upper limit. In case if the step size is not given, means it is advised, to take a step size which is like this 0.2, or means rather than the step size, you can talk about in terms of n. So it is advisable to take n at least 5. The higher the value of n you take, the margin of error decreases and you get a better approximation to the true value. So let's quickly move on to the next one. So the next one is Simpson's 1/3 rule. The formula in Simpson's 1/3 rule goes like this. So the integral of f of x from a to b is given as h by 3 times x plus 2e plus 4o. So again here h represents the step size, like in the trapezoidal rule. X is the same, it is sum of extreme ordinates. Then E is the sum of even indexed ordinates, while O is the sum of odd indexed ordinates. Now let's again solve a numerical using Simpson's 1/3 rule. Now when you do Simpson's 1/3 rule, there is a requirement over here. In this case, the number of subintervals that you break your interval AB, in this case 0, 1, into, should be even. So the value of n that we are going to choose must be an even number. As in trapezoidal rule, we agreed that the value of n for better approximations we should take to be at least 5. So in this case, we are going to take the value of n as 6. So we begin by dividing the interval 0, 1 into 6 equal parts. So divide interval 0, 1 into 6 equal parts. So the step size h is going to be again b minus a divided by n, which is 1 minus 0 divided by 6, and that is going to be 0.1667. So we have the value of h. Once we have the value of h, we can again go ahead with the table of values. So we make the table, and also here we have f of x as x square divided by 1 plus x cube. Now let us quickly make the table of values. So the first column header is going to be I, followed by xi, followed by f of xi, which is eventually yi. So this is going to be 0, 1, 2, 3, 4, 5, 6. Xi, the first one for I equal to 0 is going to be 0, followed by 0.1667, then 0.3333, 0.5000, 0.6667, 0.8334, and lastly it is going to be 1. Now let's move on to the calculation of yi. So let me show you the first one. So when I is 0, we are going to get y0, which is going to be x0 square divided by 1 plus x0 cube. So x0 is 0, so 0 square is 0 in the numerator, then 1 plus 0 cube. So we get that the value of y0 must be 0. So again, what you can do is you can enter this expression in your calculator. So x square divided by 1 plus x cube, and then you can use the calculate button and set in these values of xi's and eventually get the answers of the corresponding yi values. So let's do that on calculator, and I'll be completing this table. So with this we are ready with the table values. Now we'll be starting to develop the values that we need to substitute in the Simpson's 1/3 rule formula. So we need x, which is the sum of extreme ordinates, and here we can see that we have got y0, y1, y2, y3, y4, y5, and y6. And it's easy to map these to the index I which we have over here. So now x is going to be y0 plus y6. That's going to be the sum of 0 and 0.5, which is 0.5. Then we need e, which is the sum of even ordinates. So the even ordinates are going to be y2 plus y4. Now some of you might think that y6 is also an even ordinate. So that's true, but then since you have already counted y6 in the sum of extremes, you are no longer going to count it twice. So we are not going to count y6 in even. So let's leave it alone. So now the sum of y2 and y4, it is 0.4500. And lastly, we need the sum of odd indexed ordinate. So that's going to be y1 plus y3 plus y5, and that is going to be 0.6898. So we can now call in the Simpson's one-third rule formula. So by Simpson's one-third rule, the integral from 0 to 1 x square divided by 1 plus x cube dx is equal to h by 3 capital X plus 2 times capital E plus 4 times O. Substituting the values, this is going to be 0.1667 divided by 3 times x, which is 0.5, plus 2 times E, which is 0.45, plus 4 times of O, which is 0.6898. Now, once you feed all these values on the calculator, you are going to get the answer as 0.2311. So this is the answer by Simpson's one-third rule. And if you calculate the answer of this by, means not by the numerical methods, but by a normal way of integration, then the answer turns out as 0.2310. And if you will look at the value which we have calculated by Simpson's one-third rule, so you can see that the error is very marginal. Now let's go ahead and talk about the third method, which is Simpson's 3/8 rule. So the formula in Simpson's 3/8 rule goes like this: the integral from a to b f of x dx is evaluated as 3h by 8 x plus 2 times t plus 3 times r. Again, here h is the step size, so we'll not write about the step size. Capital X is same, the sum of extreme y ordinates. Then t is the sum of y ordinates whose index is 3 times of k. So that means the index is multiple of 3, and r is the sum of the remaining y ordinates. Let's quickly go ahead and solve a numerical and understand the working rule for Simpson's 3/8 rule. So in this case, the question is evaluate the integral from 0 to 6 dx over 1 plus x square by using Simpson's 3/8 rule, and also find the error. Now for Simpson's 3/8 rule, the number of subintervals in which you break the interval 0, 6 must be a multiple of 3. So that means it could be 3, 6, 9, 12 and so on. So for the purpose of solving this numerical, we are going to take n is equal to 6. So let's begin. So we take n is equal to 6, and therefore the step size h is going to be 6 minus 0 divided by 6, which is 1 in this case. And f of x is 1 divided by 1 plus x squared. Now let's have a quick look at the table values. So we need I, then we need xi and yi. So I starts from 0, 1, 2, 3, 4, 5, 6. Now since h is equal to 1, x0 is going to be 0, then 1, 2, 3, 4, 5 and 6. Now let me quickly calculate the yi values and get back. So once we have the table of values ready, we can call in the Simpson's 3/8 rule formula. So integral from 0 to 1 dx divided by 1 plus x square is equal to 3 times h by 8 x plus 2t plus 3 times r. So in this case, x is the sum of extreme ordinates, that's going to be y0 plus y6, and that is 1.0270. Now for t, we need the index, which are multiples of 3. So in this case only y3 is there. So this is going to be y3, which is 0.1. And lastly r, which is the sum of the remaining ordinates. So that's going to be y1 plus y2 plus y4 plus y6, and that comes as 0.7973. Now substituting all these values in the formula, we get that the integral of 1 over 1 plus x square from 0 to 6, sorry, this is 0 to 6, we get 3 times h, which is 1 by 8, then x, which is 1.0270, plus 2 times t, which is 0.1, plus 3 times r, which is 0.7973. And putting all these values on the calculator, we get the answer as 1.3571. So this is the first part wherein we were told to evaluate the integral by using Simpson's 3/8 rule. Now we also wish to find the error. So for the error, we are going to determine the true value. So for the true value, we can directly talk about the integral of 0 to x dx divided by 1 plus x square. So this is going to be tan inverse of x. Lower limit of x is 0 and the upper limit of x is 6. So this is tan inverse of 6 minus tan inverse of 0, which is 0, and tan inverse of 6 on the calculator comes as 1.4056. So this is the true value, and the approximate value which we have got using Simpson's 3/8 rule is 1.3571. So therefore the error is equal to, it is the difference between the true value, which is 1.4056, and the approximate value, which is 1.3571. So that comes as 0.0485. So with this, we come to an end of this video. If you have any other topic which you need to be discussed, you can drop them in the comment. And also I'll be attaching a separate link for the PDF file that I have created, which contains some necessary resources as well as practice questions. You can get that from the description below. If this video helps you, then do like the video and share it with your friends. Also, do not forget to subscribe my channel and press the bell icon to get notified about the subsequent videos that I'm going to upload. Thank you so much for watching till the end, and happy learning.